Welcome to part 2 of the Theremin emulator. So a theremin has two parts, or two parameters that control its sound. So the player uses one hand to control the frequency and one hand to adjust the volume. So in part 1 we took care of the frequency aspect of that. In this video we're going to incorporate the other hand, which does the volume part of that. And this is going to require us processing two streams of information at once, and we're going to need some multi-threading. So programming with asynchronicity requires working with logic that accounts for variables and values that don't exist yet. So tasks need to be handled in a way so as to account for that unpredictability. Alright, so in this example, it's not going to be true multi-threading with async IO. It's actually a single thread moving between multiple threads back and forth over and over again. So say you have two threads inside of a function. So you start thread 1, and then it's going to be executing. You start thread 2, it's going to be executing, and this is going to move back and forth between each thread, executing each one a little bit more each time till they're both finished. And then usually at the end of this, you'll have some keyword await statement that does something with all the threads that have completed. And the idea is this is faster than if you did each one sequentially, because you can complete them all, at the same time. So here to demonstrate usage, you would go asyncio.future, and this is a placeholder for something that's going to return a value later on. And another common word is await. So if we go await asyncio.future, you're going to be awaiting some future to return something which it will never do if you just use this by itself. So it'll have similar behavior to a while true. It will just, you put this inside of a function and it will make it run forever. Another way to think of the logic of this is that it's the opposite of a tautology. Like while true is a tautology, because you're asking while the Boolean true is true, do whatever's in this loop, and that's always going to be true. So this is a contradiction, you could say. Always false, and that's I bring this up because it's going to be a piece of the logic that runs the server loop, because we want that to be an infinite loop which continually tries to send data. I'll show an example of that. The way that you're going to see something like this is inside of an async function, or a function with an async keyword at the beginning. So if we had an async function that had some task where you set a variable equal to asyncio.create task of some task like starting a server or something, or finding the sound media, locating the sound device on your computer, or attaching to the webcam, or any other peripheral, you would put that here. That's like A and B here. So A and B will be asynchronous tasks. And then at the end of this, we'll go await asyncio.gather of AB. And what this does is it will be a function which waits for A and B to give their return values or complete their task. And this function will stop running after both of those finish. So the way that this is going to work in the Theremin emulator is instead of A, I'm going to put a server start task. And then this will be the stuff that takes care of the media pipe, searching for hands and sending. In the last version in the part 1 of the Theremin emulator, I was just moving the cursor. So I would call that just move cursor. In this version, it's going to be find and send hand track data, or find and send hand data. And then, of course, we would put both of those as the inputs to the gather function, the asyncio gather function. So that's going to be the basic idea of how the main function is going to work in the Theremin emulator. So this will be main. Main's going to take on this type of form in the Theremin emulator, in the Python side of the Theremin emulator. Alright, so now I'm going to run through an example of using asynchronicity and WebSockets together with the framework asyncio. So in a client-server connection where the server sends a message to the client, we have multiple things happening at once. So we'll need to use some asynchronicity. And for that purpose, I will use asyncio because it's pretty language agnostic. It's got some pretty cool things. So I'm going to import asyncio, and there's a couple different protocols you could use to send a message from a server to a client. You can use TCP, which happens on the transport layer. It's a little bit lower than using WebSockets, which happens on the application layer. Nice thing about using WebSockets is you can just send a string over the wire, a string data type. You don't need to turn it into bytecode to send it over the wire. All right, so just to recap of what we're doing here, we have a server which has a port and an IP address, and the client is going to reach out to that port and IP address, and then the server is going to send data to the client, hand track data. I'm going to use asyncio WebSockets. This function here will be an async function, meaning that it creates an event loop which is going to handle the client. So I'll call my function handle client, and this will take a WebSocket object as well as a path, and you'll see what that is in a second here. So the message that we'll send in this case, we'll just make it the string hello. Like I said, we can just send strings in this case. And then we're going to wait for the event loop that looks for the client to do its thing while we create a packet to send. That is done by choosing the WebSocket object send and sending an argument of our message. After that, we're going to have an object which starts the server, which will be the WebSocket object's serve function that will send a handle client. We're going to give this the loopback address as well as port. We'll use port 880 here. And now, complicated part, async.io's get event loop. We're going to add a listener to it. So the event loop is the one that's looking for the client, waiting for a response, waiting for the client to send a return message to the server saying, I have connected to you. Or, just connect into it and then the server sends it a message. So the get event loop is going to run until it's complete. And that's the name of the function that takes care of that in async.io. And the argument to the run until complete function will be the start server process that makes the connection or starts the server, which will do the reaching out after it calls the handle client process. One last thing, get event loop. Run forever. So this will just make it so it runs until it's done, and then eventually we'll have to close everything if we want to be clean, So that's the server. So for our client, I'm just going to pull it up, not going to type it here. I'll just explain. It's pretty simple. We create a socket object using the WebSocket class. So we used WebSocket protocol in the Python server, and we're also using WebSocket protocol in the JavaScript client. And you can see the URL header there is WS for WebSocket. That's what we have to use here. And the loopback address, the loopback IP address that the Python server is running on, and port 8080, which is the one we're connecting to. So that's what the server is running on. And the socket object, we're going to do an add event listener. This is just going to tell us when it connects. The event of connection being made will log the connected. And the socket add event listener of message function event console log message from server. That's just going to receive the message and then log it to the console. So we're just doing testing right now. All right, so now we're going to test out the connection between the server and the client and see if it sends the message correctly. So open up the client server folder. So we're going to run this server.py file. So I'm going to open up a new terminal and run with Python 3. I'm using a Mac, so it's Python 3. server. So we get into the folder server.py. We're going to run that. And okay, we're running the server. And now the client, I'm going to run the index.html, run the JavaScript file with open up live server. And that is right here. Okay, so here's the JavaScript program running. Go to the developer tools. Go to the console, and here we go. So we are connected. And the message from the server we sent was hello. That is correct. So the connection's working and the message is being sent. All right, so I will start off by making my own WebSocket class because I want to make a server. So I'm going to replace the connection that we have going here in the Theremin emulator with, I'm going to start off with a WebSocket server class because I want to have my own custom server that I'm creating, and then it has this very particular asynchronous programming that goes into getting the data from the hand tracker. So I'm going to start off with a class. I'll call it Simple WebSocket Server because it will be pretty simple. It's going to start off with it's going to take a host and port as parameters there, and also it's going to have a client that it connects to at some point, but for now I'll just set it to none. After that, I'm going to create a function that handles the client, so this is going to try to connect to it, and then if it can establish a connection, it's going to start sending messages to it. And there's a particular way that you hook up the WebSocket so that any messages that it has at that particular moment, you just send them. So I'll get to that in a second. So you start off with async and then define the function handle client. Have this take as parameters WebSocket and a path. So first we're going to set the client equal to the value of the WebSocket, which is going to be a thing that continues receiving messages, receiving messages that it's also then going to try to send at the rate that's appropriate for how quickly it's receiving them. So set self.client equal to WebSocket, WebSocket, and then we're going to do a try, exception, and then finally clause, which is going to attempt to reach out to the server. If it establishes the connection, we'll set up the thing where we, in real time, see if it has messages, see if the WebSocket that we're collecting into has messages to send. That's going to go try, async, and then here's what I was talking about, for message in WebSocket. So if WebSocket contains messages, go ahead and send them. So it kind of looks like it's almost acting like a list in this particular instance. This is like a WebSocket specific syntax that this Python library has. Oh, and whoops, this is supposed to go down there. All right, so inside this clause, inside of this loop, we're going to go await self.send. We're gonna send a message, and you do that with this syntax: echo colon bracket message. All right, then after that we do an accept clause, which will go WebSockets connection closed. So this is the case that the client's closed to the connection. If connection closed. So in this case, we'll just print client has disconnected to the console. Client has disconnected, and then the finally will be what runs after either of those clauses run. And that's, we want to set the client back to null. So that's if we get disconnected in some way, if it disconnects deliberately or whatever, we just set this back to none. After this, we could do one more function, async, there's actually two more asynchronous functions. So we want to send the message here. Send the message. And this code is pretty simple. We just see if the client is connected. So if the client is connected, or in other words, if it exists at all, we await self.client. We await the sending of the message being verified. Client.send message. And then if we don't have a client, then no client is connected. So we'll just print no client is connected. And then one more async function that's starting the server. So async start server. This just takes self. So this is the function that's going to run continuously, and we're going to use that await asyncio.future line that I talked about earlier that helps a async loop run continuously. So this is going to go, I forgot to put define in there. So this is going to go async with web sockets. This is another way to use async. So this is the WebSockets serve function. This like creates a server task. This is an asynchronous function which will run the handle client and self host as a parameter and port as a parameter, self.port. What we're going to do is indefinitely loop by going await asyncio.future. And future there is, it doesn't have an actual value, so this is just going to run forever. All right, so this is the WebSocket class that I'm going to use in this program. That's the whole thing, and I'm going to make a main function which it does everything that the Theremin emulator's main function did before, the Python function that sent the hand data, but I'm just going to add some stuff. All right, so here are the updates that need to be made to main. So import asyncio, and then that simple WebSocket server class that we just made, import that. So I made it in a Python file called server. So from server, import that class, and then these are the same. That's the same. So the initialize capture function is the same. The initialize detector function is the same. What's changing is the move cursor and send function. So I'm going to get the screen width and screen height using pyautogui.size. That's going to help get the device dimensions. And then in this while true clause, everything is the same except if hands, this is, I think that's the same. Except if we see hands, create our X and Y values that we're going to send, and then do this if server.client. So if you have a client connected, do await server.send of the X and Y data. So the way that I'm going to send the message of the X and Y position of the hand is in the format bracket X @ bracket Y. So my delimiter will be the @ symbol. And then I add this asyncio.sleep01 slight delay to limit message rate. I'm going to see how that works. I might take it out later. All right, so here's what's changing with the main function in main, in our main file. When we call main, so first of all, asynchronously run main. And then it starts out the same, the main, so make main an async function itself, and then this server and capture stuff, or this capture and detector stuff is the same. Add this server line using the WebSocket server class that we just made. Give it the loopback IP address and the port number as arguments. We're still working on port 8080. Create the server task, and right here I'm just calling it the cursor task. Might change that later, but these tasks will run asynchronously. Asyncio.create task of the server.server start. So that's referring to the class. This server equals simple WebSocket server is the class we just created. This is going to run the start server function of that server class, which was built to run indefinitely. Cursor task is running the move cursor and send task, which takes cap, detector, and server, respectively, as arguments. And then after this, we do an await asyncio.gather, just like I talked about on the server task and cursor task finishing. So it's waiting on two async tasks to finish. So these are the changes that you need to make to main. All right, so before I write the client, I want to talk for a second about the format at which I'm going to be sending the message. So right now what we're sending is bracket X and a bracket Y split by an @ symbol. All right, so that's the format of the data that we're sending. So when we get this on the other end, we want to split the data by @ symbol. And then after we split it, we're going to have like a list with X and Y separated by a comma. All right, so here are the changes that we need to make to the client script. So first we need to add a socket variable, and this is going to be set to a new WebSocket object with the parameter string ws : URL. This is the convention of WebSockets. URL, which in this case is the loopback address : port 8080. Setup function is the same. We have two new globals here. We got to initialize X and Y. This is going to eventually hold the hand data. This is where things are going to change. It's going to be like a totally new thing. So the message is, the event.data is what the message is going to be called when it comes in. So I'm going to create an array, message or MSG equals event.data, split it by @ symbol. So this is the format, like I was showing before, that it's going to come in as, where the curly brackets are going to just contain the number. It's going to be a float value. Two float values divided by an @ symbol. And I'm splitting them by @ symbol, so it's going to come out looking like this, an array with two floats. All right, so scrolling down. So I'm going to create a circle where X and Y are, so that you can follow where the hand is going, because the mouse isn't going to be moving anymore. And then for frequency here, we're going to make it just X. This actually has to be W minus X. All right, so if you run the server and then run the client, you should get this. The hand position should be getting sent and then displayed with the circle on the screen. All right, so here's the part where we incorporate two hands. So here are the modifications that you need to make to the Python file. So in the initialize detector function, you need to change the maximum number of hands to 2 instead of 1. So it's going to look for 2 hands, and then in this function here, move cursor and send. Yeah, I should probably still change that function name. Anyway, the changes that you have to make is, okay, so you go if hands, so if you see any hands at all, then label hand 1, and if there's a hand 2, which I'm going to test by if the length of the hands array is greater than 1, that'll just be cleaner when you, because if you say like if hands at 1 exists, it'll be an array access problem. That array entry doesn't exist, so you can't, it'll be with that kind of error, so I'll just do it this way. So these used to be called X and Y for the first hand that it sees, so change this to X1 and Y1, and then if we see 2 hands, which that condition will tell us, take this same code, call it X1, call it X2 and Y2, and change hands bracket 0 to hands bracket 1 in both of them. And then check if we're connected to the client. And then, so these are 2 print statements that I made to tell us if we're going to see both hands here. Print the right hand, and remember, this is the index finger of the right hand and the index finger of the left hand that we're capturing. If we see a right hand, print them. If we see a left hand, index finger, print that. All right, so I'll test that by running the client. Here is my client program. I'm going to run this, or wait, I'm going to run the Python program first, and then run this, look back in the Python program, put my hands up, see if it sees my hands, and then it should start outputting the index finger position of the right hand and the index finger position of the left hand. Let me run this again. All right, and it looks like it's performing correctly. Yeah, right hand index finger and left hand index finger, so it's given me X coordinate, Y coordinate, and then the other hand, X coordinate, Y coordinate. So yeah, it's doing what it's supposed to do. All right, so first we need to change the X and Y variables in the global space to, instead of just X and Y, X1, Y1, and X2, Y2. So do that right here, initialize them. This is the same, the connected. Okay, so when you receive the message, we need to split it up not only by @ symbol, but we have 2 coordinates, 4 components coming in. We got to split them up first by colon, and then split the 2 up by @ symbol. Split that event.data by colon, and then hand 1, that's going to be the first XY pair, X1, Y1. That's what you're going to get when you split message 0 by @ symbol. And then here label each component individually. X1 is hand 1's 0th component, Y1 is going to be hand 1's 1st component, X2 was hand 2's 0th component, and Y2 is hand 2's 1 component. All right, so in here are the changes you need to make to the draw function. So add another ellipse, that's going to be W minus X1, comma Y1, and W minus X2, comma Y2, and same with the frequencies. So yeah, let's just see if let's just try to get the data to come through. Let's not sonify them yet. And actually, that's not what I'm going to be doing anyway. The second hand's supposed to be for volume. Anyway, so yeah, let's just try to get both hands to make sure that they're being received by the client. All right, so now if you run the server and then the client code, you should get 2 circles, one for each the hand's position. We haven't programmed the sound part of this yet. All right, so here's the final part. We need to take the second hand and then find a way to have it control the volume. So my thoughts on this were to just basically do exactly what the right hand is doing with frequency being mapped along the x-axis. Just map the other hand's Y value to the volume. So as it goes lower, I figured make it, I think of Theremin, I think it gets louder as your hand gets closer to it. I forget how that works, but I think here it'll make more sense. Just, you know, the mind just kind of associates down with volume down and up with volume up. So I'll make it same way that the frequency is mapped to the width of the screen minus X. This will map to the new hand will have its Y value, the height of the screen minus the Y value mapped to the volume. So here's the way the sound was working before. When the mouse was pressed, we had a sound play. And the mouse pressed function, what we were doing was starting the oscillator and then setting its volume to, so this is just a constant. If it's 1, that means like it's playing at full volume. That first value is supposed to be between 0 and 1. And then this is just ramp time. It's not an important value. It's just how much time it takes to ramp up to the full volume. So that's set to ½ a second. And then you would set the Boolean playing to true. And then when you release the mouse, it does basically the opposite. It kind of undoes all those things. It stops the oscillator, ramps the volume down to 0 within ½ a second, and then sets the playing to false. So here, what we're going to do is just get rid of mouse pressed and mouse released. So we're only going to start, I'll put oscillator.start just in setup. So that's only going to happen once, and then I just won't use stop here. And then I'm just going to put the oscillator's amplitude thing exactly where I'm putting the oscillator.frequency function inside of the draw function. And instead of making that a constant, I'm going to make this value be, like I said, the height of the screen minus the Y value of the second hand. We're not going to need a playing variable anymore. It's just going to be playing is equal to, it's going to be like playing is equal. There's not going to be any playing variable. I'll just get rid of the if inside of the draw function, so I'll show you that. I'll show you how that's going to work. Erase all this. So before, the way it was working was I had the draw function, and then if playing is true, then do oscillator dot set the frequency equal to this function of the x value of the first hand, and then oscillator dot amplitude. This was just set to a constant. So I'm going to replace, well, first of all, I'm going to get rid of the if. So before it was like this, I'm going to get rid of this entire if and just put these two things just inside the draw function there. So I'll put it like that. And instead of that 1, that value is going to be replaced by the height minus the y value of the second hand. Oh, and this is the x value of the first hand there, the frequency. And it's going to look like that. And then one more thing. So yeah, so what I'm actually going to do there is yeah, I'm going to have to map. So yeah, there's one thing that needs to change there. I need to map the y value of x and y to 0, between 0 and 1. So the way that you do that, you go, you map, so I'll be mapping, I'll make a variable called volume. I'll go let volume, initialize a volume variable, and then set it equal to map. So map y2, map that from between 0 and the height of the canvas to between 0 and 1. Yeah.
All right, so this is the final thing that we have to do.
So we changed the logic of the script a little bit by moving around where we're going to start the oscillator. So we took out the if. Now I'm just going to have the oscillator go the whole time. Just put oscillator.start in your setup, and down here, mouse pressed and mouse released, I just commented those out. Here's the changes that you need to make to draw. So like I said, get rid of that if and just put the oscillator frequency and amplitude commands just right in the draw function. And that volume parameter that I was just talking about, put that in there. Of course, initialize it in the global space. Then like I said, frequency is the width minus x1. Amplitude is that volume parameter. So yeah, height minus the y parameter, the second hand. And I think that's everything. All right, so this has been part 2 of the Theremin emulator, and this hopefully should give you the result of like what I was doing at the beginning of the video. Although I was using pitch correction there, and I'm going to cover pitch correction and vibrato in the next video. So I'm going to design the next video in a way that you can go into it from the Theremin emulator part 1 or from this video. So if you want to just do the frequency version of this thing, or the full deal with the frequency and volume, you can do it that way too. Anyway, so yeah, this is kind of what my channel's kind of becoming right now. Yeah, I could just do. I'm just covering programs that I wrote I'm just covering programs that I think are cool. One additional tip. So yeah, I tend to have this problem where the x value of the hand tends to be like too far to the left, too far from this direction from your point of view. So the x value, the x 1 whatever equals the hand's 1 at 0. I would recommend just adding like 100 to that, just do a plus 150 at the end of that and just nudge that x value over a little bit more. Anyway, so I'll see you in part 3 or some other video that I make at some point, and yeah, goodbye.